Hi folks, let's walk through how we put together our Deltronic's parametric pin rack. I think this project is awesome because it really highlights just how powerful and amazing parametric CAD can be. And I think this sort of a storage device can be really helpful for any machine shop. The one you see here came out of a need to organize these Deltronic's pin gauges. We care a lot about the diameter of the bores on our Saunders Machine Works fixture plates. We machine them with a digital boring head, and we want to hold a really accurate tolerance. So we use a combination of metrology tools to check those diameters. We have two different style of bore gauges. We have our Mitutoyo LH600 height gauge, but our go-to is the Deltronic gauge pin sets. These are amazing because they're actually relatively inexpensive, somewhere between $10 and $15 per pin. We have them in increments of 1/10,000th of an inch, and the go, no-go nature of them gives a much more consistent reading compared to some of the other metrology tools, which are operator dependent. The way in which you hold a bore gauge or the way in which you sweep it across can actually give you a slightly different reading. As we collected more of these gauge pins, though, I realized we need a way to organize these. And so Ed came up with this rack. And the reason I think this project is awesome, and we're sharing the file on the NYC CNC site, is under Modify, Change Parameters. This whole rack is built with user adjustable parametric values. So it literally takes seconds to update the number of bins, the width, the rack height, the angle, the depth, the dimension, the thickness, which makes this an awesome tool. And if you have a CO2 laser in your shop, you can make one of these for incredibly cheap. If you don't, you can either sub it out, send it out to a shop that has a laser, check out a makerspace that has a laser, or you could also make one with a 3D printer or a CNC machine, especially a router style, but really it's best suited for a laser. So if you've never seen this change parameters or user parameters before, let me walk you through a really good example. If you head into your Fusion 360 data panel, scroll all the way down to CAM samples, work holding, yours truly, Saunders Machine Works, we created this parametric Mighty Bite fixture. It's a relatively simple fixture that you can build. It can be mounted directly to a fixture plate or held in a vise, but it's a good example of the value of using user parameters because we designed this so that it's much more intuitive for you to go in and make modifications. So having everything named with an intelligent name, a name that means something, makes it much easier to make edits to this file. So in this case, I have a stock Y of 3 inches. So that's what's the piece of raw material that we're putting in here. Let's say it's actually 4 inches. Update that. Everything moves. Let's say we're only going to use 3 pit bulls and not 5. Hit 3, it adjusts. Hit 2, it adjusts. Hit 5, it goes back. So we're going to adjust how far in is the first talon grip. Let's change that from 1 inch to 2 inches. It moves them in. Let's say you're a knife maker and you're building a knife and you're thinking, well, I don't need parametric values because we're not going to be updating these over time. Let's say the pivot pin diameter is always going to be 0.236. Well, I would argue think about still using that because can really help as you're building out your CAD file or working in a team environment. Let's create a user parameter called pivot dia, and we'll say it's inches 0.236, and we'll say the comment pivot pin diameter. Now, when we go to say model up our knife handle, and let's say we've got our handle and we create the pivot pin circle, instead of using an inch value, just start typing P and it auto-populates a list of your user parameters. Come down here to pivot diameter, hit enter, and now it listed as FX 0.236. But if you double-click it, you can see it's listed as pivot diameter. When you're then designing another component or another sketch that references this, you can use that pivot dia, or you can even take it to the next level by doing something like change parameters, new parameter, pivot clearance, and we'll say 0.0005, 5/10, click OK. And when we're designing its mate component, we could say pivot dia, pivot dia plus pivot clearance. And then when you're working with your drawings or your manufacturer or within the team and you realize, you know what, that's just too tight, we need to change that. You don't have to find this sketch, you don't have to go hunting, just come into your list, scroll down to pivot clearance and change that to 7/10. or in this case, let's make it extreme so you can see the difference. 2 thou, 0.02, like so. But it's the patterns that are really tricky. It took us a while to figure these out and get them to a relatively stable and consistent behavior where you've got each little notch correctly spaced, correct intervals, matching the other patterns of the other dividers or components. So I would encourage you to download this file, poke through it. There's some pretty clever and pretty creative formulas. And again, I don't want you guys to have to reinvent the wheel. So download this, run with it, modify it, make it what you want. The next thing I want to do is build a duplicate one of these, but for our tools. So for us on the Tormach, I have about 15 core tools. I like to have the tools set up in good condition and know that they're tools that I can use, especially when I'm using our sort of preset templates or tool libraries. That way I can program offline, get to the shop, make a part, and not feel like I've got to find a tool, set up a tool, etc. But what's nice sometimes is if the tool's already in a holder, I might want to leave an extra pack of inserts or the actual end mill box or a duplicate of that tool set up assigned to sort of that tool number per se. So my plan is to make a smaller rack like this. In fact, I really only need it to be 15, so let's make that edit right now. By 5. I think I like the shape a little better because it takes up less footprint. We can adjust the angle. I might actually mount it on the machine itself rather than have it on a cart. And now I've got a little cubby hole, and I always know that this will be spot number 3 right here for that tool. Or if I have to take a tool out to steal a holder for a new tool, I can put that tool back there, and I know that's always my tool number 3. And if you're wondering why this one's a little bit taller, we had a divider to separate out our metric gauge pins, which is, I think, another great example of it. Helps you see the design intent behind how a part was built and helps you more easily work on it or edit it. For example, on that section divider, if I click on it once, it underlines the little marching ants, so I see that that's the component for it. I could activate it, edit that sketch. It looks like it's just a number, but again, if I double click on the FX, you can see, okay, section divider offset is a dimension off a projected dimension, so that's clearly adding an offset to make that section divider slightly taller, which helps me understand, okay, that's how that was programmed, that's how that works. Go into modify, change parameters, scroll down, say 0.25, still too tall, so 0.05, slightly taller. If we go take it all the way to 0, I think it gives me a fillet error when I do this. Nope. Actually, it gives me a fillet error if I go directly to 0. I'm not sure why. Oh, there it is. I just lost the reference edge. That's okay. So comment below. I'm curious if this is helpful to people. I find it's a great example of when you have the right tool at your disposal, you make better decisions as a machinist or as a manufacturing entrepreneur. If I have a spot to put that end mill that I want to say, hey, I was using this, I'm going to use it later, I don't know where to put it. If I have a spot to put it, it makes me so much happier. It makes me feel like I can run a clean shop, an organized shop without extra effort, without sacrificing time and efficiency. Hope you folks learned something. Hope you enjoyed. Take care. See you soon.